Question 21a. A student suggests that IA is greater than IB, IA is greater than IC, and IB is greater than IC. Do you agree? Explain your reasoning. So here you have a circuit with three resistors. Value of RA and RB are equal, which is equal to R. So we can write here RA equal RB, that is equal to R. Whereas resistor RC has a resistance of 2 times R. The direction of current through each of them is shown in the figure. And we need to verify whether these conclusion drawn by the students is correct. Do you agree with these conclusion? And you need to explain your answer. So here, since we are describing current, I'm going to use Kirchhoff junction rule. So let us apply Kirchhoff junction rule at the junction here. We will call this junction as A. We know from Kirchhoff junction rule, sum of all current which are entering the junction has to be equal to sum of current which are leaving the junction. So at junction A, we have two currents who are entering. I have current IB and then I have current IC. So I can write IB plus IC equal, only one current is leaving the junction, which is current IA. So I will write this to be equal to IA. Now since IA is sum of IB plus IC, obviously IA has to be greater than both IB and IC. So IA will be greater than IB and IC. So the first two conclusions of the question is correct. Now we will verify for the third one. Now if you look at current IA, it divides into IB and IC at the junction here. We call this junction B. And how much current flows through a particular resistor depends on the value of resistance. We know that resistance measures opposition to the flow of current. So higher the value of resistance, smaller will be the current flowing through it. So RC here is greater than RB. And if resistance is greater, current through the resistor will be smaller. That means IC has to be smaller than IB. So this gives us that IB is greater than IC, which is the third conclusion. And thus we verify all three of them. And all three conclusions are correct. So we agree with the student. Question 21b. A student suggests that VA is greater than VB, VA is equal to VC, and VE is smaller than VC, where VA, B, and C are potential drop across resistor A, B, and C. Do you agree with the student? Explain your reasoning. So here in this circuit, we have three resistors, RA, RB, and RC. RA is equal to RB. They both have the same resistance R, whereas RC has a resistance of 2 times R. The distribution of current is shown in the figure. And we need to compare the potential difference across each of this resistor and verify with the student here. Now resistor RB and RC are connected in parallel. And we know for a parallel circuit, potential drop across each parallel branch will be the same. So VB must be equal to VC because both RB and RC are in parallel and they must have the same potential difference. So this is the conclusion from the circuit here. And as we can see from the question, it says that VB is less than VC, which cannot be true. They are supposed to be equal. So the third part of conclusion is not correct. Now we will verify for the first and the second. Let's discuss how VB and VC relate to VA, which is the potential difference across resistor A. To find their relationship, we will first find the equivalent resistance of RB and RC. RB and C are connected in parallel, so we can find their equivalent resistance as RBC equals 1 over RB plus 1 over RC raised to negative 1, which will be 1 over R plus 1 over 2 times r raised to negative 1, and RBC becomes equal to 2 by 3r, which is 0.67 r. And we know RA is just equal to R. After we find the equivalent resistance of R, B, and C, let's reconstruct the circuit. We get the battery, resistor RA as it is, B and C we combine together. So this is RA, RBC. The final equivalent circuit is a series circuit, and we know current through a series circuit remains the same. So current through each component in the circuit here will be I, and this current I is the same current flowing through RA and RBC. Now potential difference across a resistor can be found by using Ohm's law. We know that V is equal to I times R. So if I want to find potential difference across a resistor, I will multiply current through the resistor with its resistance. Now if the current through the circuit remains the same, potential difference will depend only on the magnitude of resistance. And since this is directly proportional to resistance, higher the resistance of a resistor, greater will be the potential difference across it. Now if you compare the resistance of RA and RBC, we can see that RA is greater than RBC, and since the same current flows through them, potential drop across RA will be greater than potential drop across RBC. Potential drop across RBC, which is VBC, is the same potential across RB and RC, so this has to be equal to VB and VC as they are in parallel. So we conclude from this that VA is greater than VB, and VB and VC are equal to each other. So here the first relationship is correct, where VA is greater than VB, but VA is not equal to VC, so the second relationship is also not correct. So out of the three relationships, only the first one is correct, the other two are not.